in today's video, we are going to discuss about the unimolecular reactions, right? So what happens is in this type reaction, it's very important to remember what's happening over here. So these unimolecular reactions are the first order gas phase reaction. So where the reactants will need an energy for a reaction through the collisions. So this is one of the very most conceptually simple types of the reaction in chemistry, and in which there will be present several mechanisms that are helpful in understanding many reactive systems. So the Lindman-Christensen mechanism is the basis for the modern theories of unimolecular reactions, which consider the formation of the metastable molecule, which will be having, a sufficient energy. Okay, so after getting the sufficient energy, it will undergo the reactions. So there will be still, this is going on. There is many difficulties. Anyway, the achievements and difficulties of the Lindman-Christensen mechanism are seems to be discussed. So we will be discussing about the Lindman-Christensen mechanism and also about some of the difficulties among this one, right? So in the next, what is the next when we just talk about the contribution of the Hinshelwood, which shows that the energy. So we will be just discussing about everything, but in shortly I will be telling everything, right? So the Hinshelwood. So what firstly about this unimolecular reaction was proposed in detail by the Lindman, right? So after that, the expansion was given by the Hinshelwood, right? So which shows that the energies of the activation is distributed between different degrees of freedom of the molecule is developed. So, right, this theoretical view of unimolecular reaction, after this one, this completely, this theoretical view of the unimolecular reaction is complete with the presentation of the contribution due to Rice, Ramsberg, Castle, and Marcus. Okay, so that means this unimolecular reaction begins from the Linderman Christensen hypothesis. After that, it's expanded to the Hinshelwood. So after that, it completes in the RRKM theory. So this will be very easy to understand how it's going on, right? So first we can just look on to what is meant by the unimolecular reactions. So unimolecular reactions are those reactions in which what happens is there will be a single reactant molecule, right? So this single reactant molecule will be converted to an activated complex, right? Okay. So this is what is meant by the unimolecular reactions. Okay. So there are two types of reactions are there. Okay. So the first category is the elementary unimolecular reaction. So this is the first category. It also have the another category, that is the reaction in free radical mechanism. First, we can just talk about what is elementary unimolecular reactions. Okay, so here what happens is reactant forms a product. Okay, so in this reaction, what happens is the reaction in this reaction, the products are obtained. Okay, these products are obtained from the reactant in single step. That means in one step itself, we will be getting what the product from the reactant through what? Through an single activated complex. Through there will be something in between. Because of that, we will be getting the product, right? So that which the process in which we will be getting the products is the process or the thing we can just tell, that is the single activated complex. Okay, so this is what mean by elementary unimolecular reaction. So we can just write an example of this one. An example is the isomerization of cyclopropane to propylene. Okay, so we can just write the cyclopropane. So this is cyclopropane. We do what? Isomerization. So it, as a result of the isomerization, what have we will be getting? We will be getting the propylene, right? Okay. So this is the first classification of the unimolecular reactions. Okay, so unimolecular reactions are of two types. The first one we have discussed, that is the elementary unimolecular reactions. And here what happens, the products are formed from the reactant through the single activated complex. And we have already discussed about one examples also, the isomerization of the cyclopropene to propylene. Okay, so next category, we can look on to the next category. Second one is the reaction in free radical mechanism. Reactions in free radical mechanism. Okay. Okay. So we have already learned about the decompositions, right? In what happens in decompositions, it is observed that they are not occurring in a single activated complex, right? Decomposition reactions are not taking place in a single activated complex. Okay, so how is the process is going, how the decomposition is taking place in then. So this is very important to understand how the decomposition. So in decomposition, there is no any single activated complexes is forming or nothing like that, nothing is there, right? So here happens the unimolecular decompositions. Okay, the decompositions, the taken placing is by the free radical mechanism. That means here the thing is the unimolecular decomposition. We can just talk with an example. Okay, decomposition. If I want to decompose this one, that is the ethane. Okay, so what I have to do? Okay, so first I have to make the radical, radical, right? So in the decomposition of ethylene, what is the first step? First step is the dissociation of ethane into two methyl radicals. Okay, and which is known as what? Which is known as the unimolecular decomposition. Okay. So one important point we have to remember in this unimolecular reactions are what? Unimolecular reactions are first order under certain conditions. Like it is first order at high pressure. If it is a high pressure, then the unimolecular reactions are first order. And if it is low pressure, then it will be the second order. I will write that one point. This is very important point which you have to keep in mind. Okay. At high pressure, it will be what? It will be first order. And at low pressure, it will be what? Second order. Okay. So this is all about what is unimolecular reactions, right? So now we can discuss on the theories of unimolecular reactions. Okay. So how does activation of the unimolecular reactions are taking place? Generally, how this unimolecular reactions are taking place, right? So if the unimolecular molecules which is activated, then only these reactions are taking place in, right? So by the process of collision, due to the collision, the activations of the molecules in the unimolecular reactions are taking place in. That means the reaction should follow the second order kinetics. Why? Because the no collisions is proportional to the square of the concentration, right? That is, number of collisions is proportional to the square of concentration. This is very important. Okay, so when will be unimolecular reaction is taking place in, how it happening, right? So if the collision is taking place in, the activation of the molecule in the unimolecular reaction take place. That means the reaction is following what? Reaction is following the second order kinetics. Why reaction is following the second order of kinetics. Why? Because the number of collision is directly proportional to what? It is directly proportional to the concentration. Okay. So this is all about the just, unimolecular reactions and all. Next class, we will be discussing about the Lindman-Christmanson hypothesis, and it's I think it's very introductory class in which we will just tell briefly about the unimolecular reactions, a simple conceptual knowledge. Okay, so in next class we will be discussing the theories of unimolecular reactions. That is the Lindman-Christian hypothesis. If I include that one in this video, what happens is the video is going to be very much lengthy, and it will be very difficult to listen to that. So in our next class we will be discussing the Lindman mechanism and different mechanisms. In next class we will be just uncovering completely the full mechanisms. That means Lindman, Hinshelwood, and RRKM. So it may take 1 hour. I don't know how many time limited which will taking, right? So see you soon in next class.